Mm. Ah, right, so here we go. Yesterday I was not so well yesterday. It's a weird thing I get from time to time. Seems to happen at the weekends. And I wake up and I've got a headache and I've got like a all-day migraine or something. It's really weird. I think I have a food allergy or something I ate. Got to work out what the pattern is. Feeling better now, but because I was yeah, I spent a lot of the day in bed, not feeling well. That's not like me at all. But it meant that I could watch YouTube, which I don't usually do very often. And I thought, have a look at FPGA programming, because I've never looked into that. So there's this nice series on there on FPGA programming. Made me think, oh, you know that idea of making a microprocessor that is capable of executing phi directly, and therefore being a microprocessor that doesn't need a clock. There's absolutely no reason why it couldn't be done on an FPGA. And the funny thing was looking at it, then looking at this thing and the language it was using, Verilog language, I was going, oh my, how similar some elements are of it to phi. So I finally found the closest thing to phi. The closest thing to phi is probably Verilog or other, hardware specification language, whatever. And then that's actually not so surprising, because the thing about such languages that are used to define circuits that execute directly and not with a microprocessor, that's what the whole point with an FPGA is. You create an actual real circuit. Classic example I give is the one of the light switch. You want to make a light switch with a microcontroller. That is, you have a button and you use it to turn on and off an LED. The only way that you can do it is for it to be in a tight loop, checking continuously in a loop whether or not the input is set, and then setting the LED to the input in this loop, which is the most expensive or complicated wire in the world, because you don't need to have a microprocessor to do that. You can use a switch and you can connect the LED directly to the button. You don't need all this thing in the middle if you just want to do that. But the thing is, it's sitting there spinning and it needs a clock. And if the clock stops, your thing doesn't work anymore. But if you program an FPGA to turn off and on a light from a button, an LED from a button, it actually configures the circuit, configures itself to literally connect one to the other internally. And so there is no clock. You just press the button and the light goes on. You take the button and the light goes off. No clock. It's clockless. And then you've got instructions which say what to do when there's a transition. So it's like if you wanted to, for example, make something that counted every time you press a button. Now you can do that with just electronic circuits. You don't have to have a computer. Again, with a computer or a microcontroller, it's going to sit there in a loop waiting until you press the button, and when you press the button it'll increment a counter and it put that out. But if you do this, you can do this in an FPGA. Actually, it's not that hard at all. And then what happens is that when you press the button, it triggers the electronic circuitry to do the count directly. And again, there's no clock. Every time you press the button, the thing counts, and there's no clock. So, and I never really thought about this before, but you know, well, maybe I was heading there. It's very interesting. So this basically means that, yeah, there really should be no trouble in making a processor that works without, you know, a microcontroller. I'm going to start. A microcontroller that can take instructions in the same way as a microprocessor does, a standard one, a standard microcontroller does, and can execute that program to perform general purpose tasks, but works entirely without a clock. It's there for the taking. All I need to do is start programming an FPGA. I'm really excited by it. You know, it's like a microprocessor that works without a clock. Yeah, can't wait. So I think what I'm going to do, now I understand why I cleared my bench over here, so that I could actually start doing electronics again. And you know, did I do that? And because I tidied it up, I feel the inspiration. Or was there something in the back of my mind that was saying, you know, get back to doing some electronics? Because I started with electronics when I was a kid. And it's actually, I find it very comforting. I think it's really good for me, because I basically grew up doing electronics. That's what I would do in my spare time. And the nice thing about it is that it's sort of more real somehow than all this computer stuff with screens. Yeah, so I've got my little flashing thing over there. It's going. Yes. That's another little experiment. Whoa! My analog, or organic, I call it an organic light chain. Hey, Mike, how you doing? Good day. And I can't, that's interesting, because that one is basically a chain of 555 timers and LEDs with the cycle of the 555 depends on a light sensitive resistor, and each one, they're in a row, and each one is pointing its light sensitive resistor to the LED that's next door to it, and they, in a freakish way that I have yet to understand, they synchronize with each other in semi-random manner. But I suspect there's more going on to this synchronization. I think, yeah, like I've said before, it's like when all the lights are on, there should be someone home. No, when all the lights are on, the frequency period of the 555s should be at their fastest. This weird thing happens that when all the LEDs are on, they all stall. They tend, when all the LEDs are on, they tend to all want to stay on for longer than they should, because the time period seems to drop tremendously and become slow, and they stay on, and then the majority of them turn off at the same time. And I've been really thinking about, why does it do that? That's counterintuitive. And I suspect there's a little more going on. I have a feeling that they're actually interfering with each other as well along the power supply, and that if I put some decoupling capacitors on the 555s, that this very pleasant but freakish behaviour will stop. Either that, or they've got minds of their own. Yeah. So that's actually a little breadboard that I set up when I started doing Kickoff Revival. So it was about 5 years old or whatever. I found it as I was going through all my crap. Yeah, anyway, enough of that. What am I doing now? What I'm doing now is carrying on with my stuff. With the Unreal engine. I'm doing it because I'm wanting to learn about Unreal. So you've been watching somebody who's not so familiar with Unreal, but been using Unity for 10 years most recently. What happens when they start working in Unreal, because I want to learn Unreal. And then I've got my project in Unreal is to make a network connected graphics terminal. It's actually just a little a graphics window that can be accessed over the network, which will allow any project to draw graphics on a window located anywhere, even a different machine. But all it needs in order to do that is sockets. It can connect to a socket to it, it can do it. So then you can build that application that uses this viewer really, really lightweight. And I'll be able to do it outside of Unreal, which I'm a great believer in getting as much as you can decouple yourself away from the technology that you're using for the actual thing that you're making, right? Because ultimately I want to use this for the Phi programming language. I want to have an output terminal, graphical output terminal, so to speak, that the Phi language can operate, so that I can demonstrate some time-based things in the language which will actually help solidify what the point of Phi is and how Phi can work in game development. So if I'm doing that, but can you imagine I'm working in Phi and then I'm having to deal with all this? Oh, okay. Unreal crashed again, you know, or yeah. I mean, because if I put the embed the Phi virtual machine inside of Unreal, I could do that. But you know, I'm a human being. I'm not perfect. I crash things. It's normal if you're a programmer. It's normal to have crashes while you develop your software. I don't think there are many programmers who never have a crash. I hear stories, but you know. Well, I'm certainly not one of those. I do my best to get it right, then I test it, and then it crashes, and then I fix it, and you know, doing this what you do, and you get there and you make progress. But can you imagine if I was doing that? It would just so annoying. I'd be going restarting Unreal, you know, many times a day, and it's slow to start Unreal, and then you have to the compilation time and the linking time, and it's like and all I'm doing is working in almost one CPP file. I think the virtual machine, which is a prototype one, not final code, of the Phi virtual machine, is practically in one CPP file. Phi and FPGA, I just can't wait to start with that. I've not done any FPGA, and that will be a good thing to stream as well, you know. But anyway, yeah. So if I was to, so what I want to do is, now I've done this many times in the past. Although usually I do it when I get pissed off with the environment that I'm in, so that out of desperation I do that. I've done that with Unity at one point for making UIs. But this time I'm going to start with it. Why not? And so that means I need my network terminal. And so I'm making that in Unreal to at the same time learn Unreal. And I'm making it in blueprints in Unreal because at the same time I want to understand and be fluent in the interconnection between C++ and blueprints in Unreal. It feels like a very important thing to understand and get right with lots of interesting architectural questions. So that's kind of very interesting. So as usual, I'm sort of doing more than one thing at a time. Everything I do is usually there's multiple strands. And you can see the current state of play of where we're at in that text in the middle of the screen there. And at the moment it says phi dev. That is the master thing that's driving the current line of research, for which I want to make a nugget window, nugget being my network unified game generation engine and tools architectural framework. Yeah, so the project for that is Nugget Window. That's making a graphical window that operates with the Nugget philosophy, and part of that is networking, or at least extreme decoupling. Let's put it like that. And I'm doing that in UE4, which I'm learning, and currently learning networking. So I'm learning networking in UE4 for the purpose of making Nugget Window, for the purpose of continuing phi development. Eventually, sometimes I end up going, it gets deeper because I end up going into something else. But eventually, it's like that thing, the Tower of Hanoi. It's really just like that, and it goes longer or shorter. Eventually, I'll get to do phi. When I get back to phi development, when I'm ready with that, I will be streaming from the other channel, which is the phi language channel, which will be specifically about phi. So there we go. Bulletins out of the way. Nugget in blueprints, yes, absolutely. The point about the architectural framework is that it can be applied to anything because it's an architectural framework. The language does not matter. If I had a big message that I would like to spread to the world about programming, is the language doesn't matter. Not really. I mean, when you're learning initially, the language matters because you have to learn the language that you're learning, right? But at a certain point, the real heavy lifting is not typing. It's or even choosing which syntactical constructs are the best ones for you to use. The programming is really about where the heavy lifting of programming occurs is in architecture, whether you like it or not, and whether you call it architecture or not. And an architectural framework will be applicable across different technologies, different languages, and so on. So phi in itself there's a programming language called phi, but you could also say that phi is an architectural framework as well. And because the principles behind phi could be replicated in many different technologies, forms, or languages, and as Mike was just saying, if you just joined, I said this at the beginning of the stream not so long ago, is that the idea of creating a microprocessor in an FPGA that doesn't need a clock, that doesn't use a clock. And so the point with phi as a architectural framework is that it's applicable from hardware through to any language that you use. If you make phi in a programming language, a traditional programming language, it's interesting because you're creating a language that doesn't require a clock or program counter. They're kind of rather connected. doesn't have a program counter, so therefore it doesn't need a clock, but you're creating it in a language that has a program counter and a microprocessor that is driven by a clock. But even then, you can, what you do with that, you say, well, how does that work? Well, in the end, what you do is you'll have something that spins in the kernel of the language, and that's being driven by obviously your traditional program counters and clocks and whatever else, and it construct you with it. You construct a virtual machine, and that virtual machine is not physical. It's a kind of logical machine, you could say. The logical machine can work by any rules that you want to work by. So it can then work by the rule of not having a program counter. So then what you're actually doing is you're using a clock and program counter to simulate a machine that doesn't have a clock or a program counter. I find that really quite satisfying, actually, as a concept. So using a von Neumann architecture to create something that's not a von Neumann architecture and isn't even a Turing machine, although it is Turing machine complete. Ah, boy. How can it be Turing machine? Because you can make a Turing machine out of phi. But phi isn't a Turing machine, not, class of thing. Yeah, so if you're interested in that, in that weirdness, which I'm very excited about, I'm very happy I've finally unleashed it and came out about this crazy idea that I have. I let the world know I had this crazy idea. But actually, the more I think about it, the more I think there is something in it. Even the concept of having a CPU that doesn't require a clock is significant, because it means that the list of reasons why this is a good thing. I mean, aside from less power, because there isn't this clock spinning, so you immediately can create a CPU that requires less power. But also, if it's operating with memory that is non-volatile, you can stop and start it whenever you like. Theoretically, and everything's fine. Theoretically, a machine built on a computer, built on a microprocessor that operates with a phi architecture throughout the machine, which I have to say would be a massive undertaking, because if this is a bona fide, it might not be, but let's pretend it is, or maybe it is, but who knows? But if it is a bona fide new computer architecture, or at least a computer architecture that, if not new, got forgotten or ignored, if it is whatever, if it is something like that, and you wanted to build technology equivalent to the computers of today, you see, the von Neumann architecture has a lot of time ahead of it, because it's been around for 60, 70 years. So there's quite a bit of catching up to do. So to make a whole computer that ran, even an operating system that ran on phi, probably actually not that difficult, but still. But if you had a computer that ran using the phi architecture, when you turn it off, if you use non-volatile memory, you could turn it off and then turn it on again, and everything will be just where you left it. Everything. Everywhere in the code. Because that's one of the problems that you've got with von Neumann architecture, which is the basis of all computers really these days, is that when you start the computer, because if you've wondered why it takes so long for the computer, hey Mark, how's it going? I can pay extra for the Turing machine. That's right. Well, just think, we could end up with computers, Turing machines that emulate phi machines that implement Turing machines that implement phi machines, and it just goes on. Yeah. Anyway, The thing is when if you ever wondered why it takes so long for your computer to start up, it's really aggravating and it's stupid on a certain level. It's really especially stupid when you compare it to the startup time of the Acorn Atom, which is like instantaneous. Hey, tropical banana man, how you doing? You know, why does it take so long? I mean, surely you can just, like, it's there. Okay, you can use Hibernate Mode. So in Hibernate Mode, it has to re-pull all of, it saves everything to disk and pulls off the disk into memory, and the thing starts up again. So yeah, you can sort of do it, but it's kind of slow and clunky and prone to crashing. And in any case, why is it that your computer, every time it starts up, has to go and reinitialize everything again? Now, in part, it's got to do with things like hardware and so on. But if you think about it, to construct all of the memory of all the programs running in your computer required that the microprocessor execute series of instructions, right, which are nested. Okay, and then if you turn the power off your PC and you just sort of restore, you're able to magically restore the state of all the memory, you still have a problem that you need to somehow get the microprocessor back to the same spot that it was in. Right? You following me? It's like you could just turn off the computer, turn it on, restore all of the memory, but somehow you have to get the microprocessor back into the precise spot that it was when you turned it off. Why? Because you've got a program counter and you've got a stack and you've got this chain to get to this point, and that chain to get to the point is a real problem. It's just a problem in general. One of the issues that you often, it's a very big issue, is this question of exceptions. When something goes wrong and the CPU throws an exception, what's it supposed to do? I mean, it's sort of like something went wrong here, but the problem is this here, if you trace it back, had an origin somewhere up here, maybe when you started the application that crashed, right? How can we make it sort of deal with this gracefully? Well, you can, but it's difficult. There's a whole thing about it in languages. Exceptions work quite well in C Sharp, but C Sharp is a virtual machine, runs on a virtual machine. If you want to do these exceptions on an actual, in C++, it's running directly on the CPU. And it's tricky. There is try catch, which allows you to try and catch an exception no matter where it got generated down the stack. But it's gnarly, doesn't always work. You can't actually use it in Unreal, which is why I made my own to solve the problem of how to have an assert inside C++ code that's run from blueprints without it crashing the editor. Is another example. It's because we're down here and something goes wrong, and really, if we don't want the application to crash, we have to sort of gracefully jump back to some point where you can say, okay, that didn't work, but we'll just let the application continue. This is really tricky. But you don't have any of that with Phi, because there is no program counter, there is no clock, there is no stack. At least not in the same way. The closest thing to a stack in Phi is a scope, and it's because every operation is kind of logical. Well, that's the right way of putting it. It's a function in Phi is a block of state while it's executing. It's a block of state, similar to the blocks that you would have in a stack, but there's absolutely no reason for it to be done as a stack. So in theory, if you turned off a microprocessor that ran using the Phi architecture, as long as it had enough time to finish the instruction it was currently executing, theoretically, you could turn the thing back on and it could just continue from where it left off. So I kind of find that quite compelling. You know. Anyway, I digress, because I'm going to get back to this thing here. If I try to get my thing here up, there we are. There we go. It's the code I'm working on. And where did I get to? We're going to have a look at this blueprint. This is one of the things about blueprints. Look at this blueprint. It's like, oh. So some of these other ones, these are old blueprints that I'm not using right now. I'm just move. There you go. I'm going to move these out of the way. Yeah, it's like old unconnected code. This is the current blueprint here. It sounds too good to be true. I know. What is the problem with it? There is, like with everything, there is a problem. It's not all plain sailing. The problem, you know, because it wouldn't be any fun if there wasn't a problem. The problem, and this is where the main research into Phi will probably have to go. The problem is that when executing an instruction, let's put it this way, when executing a rule, because they're not instructions, they're rules, program is a set of rules, it's possible for two separate rules, you can specify two separate rules to change the same value. And if it tries to do that at the same time in the one rule execution, to modify a value twice, that would be a problem. So this is because it wouldn't know which value to use. So what you can get are conflicts in the program that you specify. You can specify a bad program, basically. A program that will have an event that logically should not be allowed to happen. So you get something like this with FPGAs. If you try to set the same wire from two different paths at the same time, it's actually impossible for it to construct a valid hardware for that. Because you'll end up with an indeterminate answer. If one path tries to set it to true and the other path tries to set it to false at the same time, yeah, it's similar to that, similar kind of issue to that. So what that means is that it's still possible to have programs that crash, technically. Except it doesn't really crash. It's not really possible to crashify program in quite the same way. Let's say it's because it just doesn't mean the same thing. It's not that it crashes, it's that it does something that throws an exception and says, oi, I can't do this. So then I have to figure out, well, what do I do when that happens? How much is it, in the runtime machine? The other question is, how is it possible to make the compiler or the interpreter identify this problem? Is it possible to prove program correctness, where program correctness is defined as a conflict never occurring, and it may actually be possible to do that. It sort of like requires some graph theory, I would think, but or at least to help mitigate that. So yeah, there is always going to be an issue, but my argument is that that issue is, I'll take that issue if it means getting rid of the multitude of other ones that are a problem, like for example, dealing with threading. How does Phi deal with threading? That's the hilarious thing about Phi. How does Phi deal with threading? Doesn't have to. at least in theory, it actually doesn't have to deal with threading, multi-threading. I believe that to be true, but we will see. we will see. But if you're wondering why is it that Phi doesn't have to worry about threading, I can reply the FPGA thing is great because it helps me talk about this. It's like, does an electronic circuit need to worry about threading? No. It's not relevant. So in an FPGA, you're doing parallel execution all the time. It's right, because you're building circuits. Have you even my little flashing lights over there? There's 5 cores in that. 5 circuits that run independently. Not having to worry about threading because it's an electronic circuit. Again, it comes down to the difference between an electronic circuit and a computer. As we under von Neumann architecture computer is the damn clock and the program counter. You get rid of that. Yeah. It sounds so great. You're almost daydreaming. Yeah, it's great. In theory, it's. Well, you can imagine. When I started, when it first hit me, I was going, no. Surely someone else must have thought of this. I'm sure someone else did, but I'm going to talk about it, and I don't know who else thought about it. But in a way, as I say, it's really not that new in the sense that it's been existing all the time in electronics. You know what? I think that one of the problems that we have. I mean, sorry, I'm going off. But it's an interesting topic. It's like the history of computing. Something went wrong. In a way, it's way back when computers were first constructed. The problem was how to actually make them work at all with valves. And I was reading a book that was talking about, I can't remember which book it was, but it was describing, the time with Alan Turing's sort of era and the early computers, and how even all the way back then there was a stigma towards engineering. You would have the academics wanted to be theoretical, you see, and they really didn't care what it took to make the computer work. It's almost like the engineers were there to do the mathematicians' bidding, and they're the ones who actually built the machines. But the problem was how to make them work at all. And I wish I could remember his name, but there was this guy who was utter genius as an engineer, experimenting with bicycle wheels to store data. It's like, I mean, actually, it kind of makes sense, It's just like what you do is you could, if you wanted to make a kind of fake hard disk, it wouldn't be that hard. What you would do is take a bicycle and take a wheel and put an electromagnet on one side, and then you could magnetize the wheel and pick up the signal. And if you made this thing spin, you would have memory. And so a lot of early computing was all about that. All about ways of creating memory devices other than as a valve, because you could make a bit in a valve. Valves were about this size, and about a thing like this would be 1 bit. It's like, well, good luck there. You need a lot of bits to make a computer work. So if that's 1 bit, right, can we think of a way of compacting this? And there's so many weird and wonderful ways that was done. I'm not an expert in this area and this history of this, but there are a few things caught my eye. For example, one of the earliest computers, I think it was the EDSAC, they had a memory in long tubes of mercury. So it's a long tube, right? And it had transducers at either end. One that would transmit, in effect, an audio signal, and the other one that would pick up the signal. Now, mercury, being quite a heavy, dense liquid, was very good for transmitting a sound wave through slowly. So what you could do was send a bunch, you could encode a bunch of ones and zeros by sending it to the transducer at one end of the tube. Then what would happen is that would move all the way through the tube. I'm not making this up. This is true. I mean, it sounds ridiculous now, but it would go all the way down this tube, hit the other end, and be picked up by a microphone, in effect, right? And then the electronic circuitry would be some valves that run this, the driver, would send that signal back to the beginning. So what would you have? You would have continuous feedback with a time delay. And now, whatever pattern you sent in would go through the tube, out the other end, back, would be memorized. And you could read that signal out as a serial signal, and you could modify the signal. It's utter genius. It's almost a solid state tape loop. This stuff is great. But the thing is, with a tape loop, you can stop the tape and it still remembers, right? But with this mercury thing, it's like dynamic memory. You had to keep refreshing it, otherwise it would fade away. Another one was using a CRT. So the tube, you know, the old TVs, people they're forgetting what old TVs were. TVs with a big tube thing, you know, like on YouTube was named after the tube. We sometimes called the TV the tube. It's because it's a big vacuum tube, or, you know, these things. So what they do is these have existed for a long time. They figured out that they could make a oscilloscope tube like this with a beam going across, and what you could do is write your binary pattern in it, and then the phosphor on the tubes have a certain fade time. When you light up the phosphor, it glows for a certain amount of time. It doesn't immediately go out. Oh, so if you can detect whether it's lit or not, they could with electronic circuitry on the tube itself somehow, I don't know the details, you could just keep refreshing it. So what it means is you could put an image on the tube and it would stay. And again, it's the same principle. This is another way of storing a lot of dots, a lot of bits on a small thing. So they made computers, with the early computers used this as well. And there's this guy experimenting with a bicycle wheel. But the point being, there was a point to this story. The weird and wonderful things that went on as far as engineering was concerned, these were looked down upon. They were not considered to be proper science. Which is quite funny, because, you know, what is science? It seems like science to me, but there was a stigma against it. So this guy who was a brilliant engineer, was never really recognised, and it's all very sad, you know, and all the rest of it. But what happened as a result is that the computer that we have today, the architecture that we have today, is the result of constraints placed upon engineering, which have been ignored as much as possible by the people who developed programming languages. I'm exaggerating a little, but more or less is the case. If you go to, I remember going to, when I was teaching, I was looking into maybe doing a master. I went to the University of Utrecht. They had a master in computing. I remember going up and asking the troublemaker as I am, going up and asking the person, you know, who was telling us about this thing, Why is it that in computer science courses there's very little about actual computer hardware? And he gave me a very strange look. It's sort of like, because back then I was thinking, well, maybe there's something in like a different architecture. Do we have to use the von Neumann architecture? Why do we only use the von Neumann architecture for our computers? I tell you why. Because as soon as the academics, and again this is a bit tongue-in-cheek, but I do not mean to offend, but there is an element of truth to this, that when the academics got something that basically sort of worked, there was no money in there was no interest in exploring some other alternative. So basically we've had a lot of research in computer science that's all been focused on theoretical things such as programming languages, while the engineering has gone on to serve this on the other track. But there's not been much in the way of research in actual computer architecture as a fundamental thing ever since. We've kind of, there were the analog computers at one time, and they, for real, for good reasons, they, stopped to be a thing. That's an analog computer. My five circuits over there, the lights. But yeah, the analog computers, they weren't really practical, and so there are reasons why they disappeared, and we were just left with one architecture. And surely there are other architectures that could have been possible. Why haven't we been researching them? Instead, the research has gone into improving the von Neumann architecture, and most of that has been involving expanding the memory and making the memory faster and making the processors faster. And so, of course, there's been a lot of research in that, and that's huge. And been going on for a long time when we've taken it to incredible levels. But I'm saying that really, if we're going to research a topic, right, there should be, one could argue, there should be probably, there could be other avenues that weren't explored because it wasn't convenient to do so at the time, that if they had been explored might have taken us somewhere else. And the spirit of academia in my book should be to do that, to explore the non-obvious, to look for alternatives, right? And so I kind of wonder if it was a bit of a mistake to just have mathematicians doing their thing, being served by engineers, and there never being a proper integration of the two things. And this is why computers today are basically number crunching machines that were originally envisaged as things that ran programs and stopped. And that's how they were. It's like, we need to calculate the square root of 3,228. So run the program, here's your answer, program stops. Like, hardly any programs running on computers these days do that. They don't stop. Unreal is here, it's still running. The editors run, the computers run, they're all waiting for key presses. The computer was never designed to wait for stuff. It was designed to be given it was designed to take punch cards. I mean, literally, there's really no difference between that and what we have now, in principle, except that instead of cards, it's in memory, or you download it off the internet or whatever, right? But you would have the program, would be a bunch of cards, and you put it into a punch card reader, and it would load up the program onto your computer, right? And then you would have the data that you'd want to process, and that would be a load of punched cards. Where they came from, maybe someone had typed them in. They would have machines where you would type in to this machine, and it would create the punch cards. Anyway, you'd have the bunch of punch cards, right? And so you put your program in, and then you take your data and you put it in, and well, you didn't even put it in. You would run the program and it would start pulling the card data out, run whatever algorithms it needed to do, and generate some punched cards. That's it. Run the program, and then it would stop. So the idea of interactive software, it's just like, you know, programs that never terminate, multitasking. The architecture was never designed for that. And I just find that fascinating. Now, I could be talking, in all fairness, I could be talking a load of rubbish. But I'm not sure I am. I could be deluded, but I'm not sure I am. And I haven't really had anybody argue with me when I presented this this case, because I'm not sure there is an argument against it. I think it's exactly what happened. And there we go. Ah, that's good. I got that off.
Dino.
Yeah, hello, Hal. You see, Hal, the AI, it picked the right moment to say hi, didn't it? Just at that moment, just let me do the rant, and we just get to the end, and somehow it is uncanny as hell. It's just voice attack. It freaks me out sometimes. I'm going to read the text, and then I'll get on. Does Blueprints have a tidy feature? No. I mean, you could probably write you could probably program a neural net to untangle the net. I don't know, but no, I don't think it does. Yes, I'm looking forward to doing more electronic experiments. I'm really, really keen to do that kind of stuff because it makes me feel good for some reason. The old ranting time, yes. Patent mining, academia, bicycle wheel. Yeah, I know, bicycle. I mean, it's so crazy. I might want to try it myself, just because, you know. Imagine how painful it was to play FPSs on that. Yeah, it would be very, very painful. Yes. What's more fun than standard modern way, anyways, if you're practical? Oh, Mike, here we go again to corporate screen. You know, yeah, we're not rubbed out yet. No, I don't know. I mean, you can't even drag the wires around. Maybe that's a good thing. It's, well, but the point here is that, to go back onto topic, because I was way off topic there for a time, but I've been meaning to get that off my chest for a long time. The point of this exercise is, this notice event is a different thing. I can actually just I'm not using that at the moment either, so I need somewhere for it. It's like, look, it's so important. It's so important. You know, don't ever have files with lots of lines. Try to make sure that your code is nice and clear. You know, don't write spaghetti code. Go-tos are evil. And whatever you do, don't do that. Dear God. Put code on top of code. It's just so painful. So, sorry. Focus, Dino. Focus. You're getting too excited. You know what happens when you get too excited? You know what happens? Yes, along comes a troll. So what happens here is on event play, it goes to a print string just so that I can see. That's a DevOpsy thing. That's just so that I can tell where the new log starts. And then a listen socket is opened, and then it waits until there's a connection, which is done with a loop. Now, the reason it's done with a loop is because I'll need to make a latent action, as it's called. Delay is a latent action. A latent action that actually does the wait. And that is possible, but I will do that later. So that's a loop that waits for a connection. When the connection arrives, it's going to accept the connection. It prints a string to say that the connection was accepted. And it runs on to another loop. This loop, it's waiting until there is data on the accepted connection. When there is data on the accepted connection, this returns what? Where do you go? Ah, right. True. So, oh dear. Comments on your code are very important. It's so important that as I move this around, I get these pop-ups, and they just, because, you know, you've just got to have them interfering with your view all the time. I did figure out how to turn that off, but it doesn't remember the setting. So then I have to look it up every bloody time. But anyway, so print string, it's going to be stuck in a loop, waiting. Here's the loop. Wait, is there a way of making this pretty? It sits in the loop until eventually there is some information. When the information arrives, it takes a buffer and resizes it to the size of 1 currently. Then it calls socket get data, and socket get data, which is also a function I've written. So basically anything called socket here. So I wrote that and that and that and that. This is going to read 1 byte of data from the socket, and then it should print it. Hang on, except it's very confusing, this. It's confusing. I had to check it myself, because in fact what happens is, and this is the way blueprints work, this buffer, which is an array of bytes, has been set to a size of 1 at this point, and when it gets socket data, it actually puts the socket data back into the buffer, which is sort of counterintuitive. So it comes this way and it goes boom back into there, because this buffer gets set, because this is a reference. So basically blueprints is basically C++ code in effect. So you get to do all, on top of all the ways that you can really make horrible code in C++, you can also make it look utterly indecipherable and horrible by literally putting it together with spaghetti. So there might be a way.
Hello, Dino.
Yeah, hi. There might be a way of you know, making sure that you don't write spaghetti code in blueprints. But whatever method you might use to avoid spaghetti code in blueprints will involve the use of spaghetti. Anyway, when the data from this that's been read in gets put into the buffer, then we want to print it. So it then goes to the print statement, and the print statement gets from the buffer by this path here, where it goes get element 0 of the buffer, and then which was the one, element 0 being the 1 byte that is just read, and then it gets converted into a string and it prints it. So that's it. So why do all of this? Because the great thing about blueprints is that I can make changes without having to recompile the code, and that is good. It's not so bad now there's hot reloading, but I think there used to be the case that you would have to restart the whole editor every time you edited the code if you didn't do it in blueprints. So in fact updating the code's pretty fast now, but still it's very good to be able to do that. So what I'm doing is using blueprints as a way of prototyping and building my code incrementally, which is why I've got all of these exposed. Because you could quite rightly say, why on earth are you exposing all of these things? You could just write them all in one function. And so eventually I will provide that functionality. But it's kind of nice to be able to go down to the base level, because then I can experiment and debug my network code without having to recompile all the time. So there we go. I hope that made some kind of sense. Multi-threading. Yes, there are many threads, many threads in here. But yeah, I mean, the white is the program counter. So imagine, you can see right here, it's a lovely demonstration of the problem of the program counter. If you wanted to, if you could write a programming language that didn't have a program counter, that would be about equivalent to getting rid of all the white lines here. And if you got rid of all the white lines here, it would be much less messy. Yes, there is. You can create functions. So in the same way as this is this, say, socket accept here is a function, you can create functions in blueprints. You have a blueprint function that you can then call. And good luck to you if that becomes very complicated, because it's actually quite difficult then to navigate through this to make sense of it. So I like it as a tool for development more than as a tool for production at the moment. So there we go. What? Oh yeah, look, this is kind of toggle. Make the flag not flag. When this goes through, it reverses the flag. So as it goes through, it has to take the current value of the flag, it sends it into a knot, and the output of the knot back into the flag. There might actually be a not function, I suppose. I know there's an increment function. So anyway, I've done a lot of talk and not much work at all, and it's like I'm now been streaming for an hour. So that's pretty bad. Let's go and see what we've got here. This is Netcat. Netcat connecting to port 7777. It doesn't connect. It doesn't give a warning. It just sort of times out. Now, if I hit play in the editor, and now I connect with Netcat, it doesn't return because it does actually successfully connect. And down here, this is the debug text. You can see that it said accepted connection. Almost says upset. There's a typo. Accepted connection. And now, if I am in here and I say hello and I hit enter, you can see that 104, 101, 108, 108, 111 and 10. That is HELLO and new line. So this is successfully receiving data. This is receiving data from Unreal is receiving data from my terminal. That's pretty good. Unreal has got a console, hasn't it, that you can activate. So I always really think it's a nice idea to make the console something that you can connect to over the network. Then I can just do and I could send commands. Basically, this means I could send commands to a running program, a running game in Unreal, like a console, but I could just send them with a Netcat. And that is much better, because then you can sort of send files as well. And you could get it to send files back to you. In fact, it can be quite nice to embed a web server So that might be something to do, is to make a little mock web server that sits inside Unreal, and then I can have a web page that manipulates the running game. You know, it's like I first did that in 1990, before 2000. I did that. I embedded a web server inside game running on the PlayStation. Yeah, you could get, if I remember rightly, if it wasn't the PlayStation, it was on PC, but I'm pretty sure I did it on PlayStation. I know for definite I did it on PC for a demo. You could just click on a link and it would give you a screenshot. You know, it's like, yeah. I don't know why there's this reluctance to do networking, because networking is cool. And it's really fast. It's faster than the connection between the graphic card and the pixels on your screen. But that's another story. I'm going to end up ranting again. I've already ranted. So what am I going to work on next? Well, one of the things that slightly concerns me is I want to... this is always a bit of a pain when you're working. Hey Tony, how you doing? When you want to do some things with sockets like this and set up some kind of bespoke network protocol, and then you think about how you're going to arrange the data packets. So I'm just thinking about that. I know that in the end I want to be able to send a command that can move objects and create objects, and actually we could do it by name. Do it by name. Shall I just take strings? And then I start thinking, well, you wouldn't want to do it with strings. Strings are slow. Yeah, but this is 2021 now. Strings are slow, but they're not as slow as they used to be. I could get it working with like a text-based thing. This would be a lot easier to debug. It would be easier to debug, easier to get going. I could optimize it later if I needed to. Why not? I just use a string, and I often fall into this one because, you know, why do it with a string first? Make sure it works. Once it works, then you optimize it later. The shortest path to making progress, but remembering that you will need to optimize it. So I'm thinking about how would I optimize it. But I suppose, yeah, where I have a command as a string, I could replace it with an ID. I could do everything with IDs. I could then later switch it to being binary if I wanted to. I see no reason why I shouldn't implement in the first pass as just string commands like a console. So that's what I'm going to do. Decision made. But then the question is, how do you send a string over the network? That's a little bit annoying because you don't know how long the string is. Pardon me. You don't know how long the string is as you read it in. On the receive, when the receive is done, you will... Yeah, I can use a single byte, but I want to be able to... You see, if I do a text string right now, then it means I could debug this by using netcat, and I don't have to sort of create the client side yet. It's breaking the problem into two halves. I can use netcat to test it, but it's harder for me to use netcat if I'm using a binary. But netcat will send, as you can see there, a command. It will be ended with a 10. So how do I know where the 10 is? Well, I could just keep reading. I could read a chunk at a time. Like I could read 256 bytes at a time. As the bytes come in, I could search for a 10 new line. I could process that and just remove it from the buffer. If I read 256 bytes and there was no 10 in there, then I'd need to let it append, or I could make it a rule that I won't allow strings longer than a certain length. I think I'll do that for now. I'll use 256 byte string. Well, you know, how much of this am I going to do in C++ and how much in Blueprints? I think at this point I'm going to be a bit stupid for me to try and break this down using out of Blueprint components. I've just got to go. I've tested the API and it works. I can get socket data. I'm going to write a function that's a Blueprint function to get a string. So that's what I'm going to do. I need something that will do this. Get socket data. At the moment I only support one socket. That's something I will also extend later. I don't know how we'll do that. But it would be nice if I've got that. Get string, socket get string, and it just returns a string that it gets. So and I could just implement that in here. I don't enjoy this buffer programming that much. There's so many edge cases lurking. I don't really find it that fun, but it's got to be done. I can create a buffer to receive the data initially. Choices. Yeah. Yeah, okay. I think I can do it as a uint8 array of a particular size. Maybe we can set the size at const int max len 256 uint8 buffer 256. The danger of overrunning with this, but it's the way this works is the way it works. This is the API. It fills a data address you point to, so you know that's it. I can specify the length that I want, and that's going to be but there needs to be a persistence between. There needs to be persistence between calls. I just want to get something that works initially. I'm going to create, because again I'm building this as a one-off for now. To refactor to handle multiple sockets later is such a small task really. once everything else is working. I don't want to worry about that at this time. I'm going to do uint8 buffer max string let's call it max receive length. Max receive len. So what I've done is created a buffer that is right. Let's change that to that 256 max. Right, so there's a buffer that is going to be persistent between different calls. Get socket get string. We get the data into this buffer with a length. Well, let's put those in as well. Now with that, I'm pretty sure I'm not going to overrun this temporary buffer. I read everything I can. The amount that was actually read is going to be in read count. Oh. So that's in read count. We read in what we can up to 256 and we'll get a certain amount out. Now, one of the problems is that it's unlikely, but it's possible that for some reason the string was only partially sent. And you can debate about whether it's really likely that it'll happen or not, but I just want the damn thing to work. So that actually is a point. I could find myself in a situation where what I receive doesn't have a 10 in it, a new line in it, but the new line is still coming.
Hello, Dino.
Yeah, every time, every time I sigh, Hal thinks I'm saying, hello, Hal. Hello, Hal.
Hello, Dino.
No, that's not doing it now. That's because I drew attention to it. I'm just thinking of the best way. I mean, I received this thing, and did I get it? No. I don't like this kind of programming. Not my favourite thing. Did I mention that? You receive. If I could receive the data. Well. And anyway, I say data, get data. What's that? That's because I was copying the other code there, where I was getting it into this T array thing. So that's off. In fact, what I want to do is, yeah, has to be a genuine site. I know. Then Hal tries to cheer me up.
Hello, Dino.
I got it. I fooled you, Hal. That was not a genuine sigh, but it sounded like one. Yeah, you were fooled. So, or maybe Hal is fooling me. I mean, somebody's fooling somebody. The biggest fool is the one that doesn't know who's fooling who. Well, I'm just going to keep prototyping here. I've got an integer called buffer point. I mean, and that's always, well, it's really unnecessary. It will be 0 anyway, but it's 0. And I'm just going to try something out here. And this I'm going to get rid of. I don't like that. Now, what's going to happen is I'm going to pass in the buffer bugger. I don't think it's a coincidence that the word buffer and the word bugger, they're very kind of similar, because it's like it's full of these things can be full of bugs. So there we are, and you end up saying, "Oh bugger." Buffer plus buffer point. Yeah. Shut up. Buffer point. So what that is doing is basically saying, let's tell it to fill my buffer up from the last point, which I've got buffer point. But I also want to know how much buffer is left. So the max amount that we can receive into the buffer is the max buffer. Oh, it was there. Max receive length minus buffer point. Buffer point. I just realised that when typing, the word buffer is very, very problematic. It's a, yeah.
Hello, Dino.
Shut up. So buffer plus buffer point. So what would happen then is that we would be filling the buffer at buffer point, and it still cannot overrun the buffer because I limit it so it won't pass the end of the buffer. And then here's the actual number that has been done. And then you've got your read count. Yeah, how much was done. Now, what I need to figure out is how to handle that, because no, I don't need to figure it out. I've read it. Right. And, buffer point. Yeah, it's not too bad. Buffer point. This is not going to be the world's most efficient code, but it should work, which is what I care about. Plus equal read count. So what basically is happening is it will put it into the buffer however much I receive. The maximum I can receive will fill the buffer, that's 256. But whatever I get, if I only read 3 bytes, they will have been read into the buffer, and I move the buffer on by that amount. So in that way, I always have inside buffer the most recently obtained stuff. The next thing I need to do is find, because it's looking for a string. But this should be non-blocking. Ooh. Yeah, so I'll also need a function that verifies if a string is available. I'll come to that. Need to know if a string is available. Excuse me a moment. It's going to cold. Step away from the camera. Why? Oh gosh, there's not enough light in here to do this. Yes, so I'll need a function that will check to see if a string is available. When a string is available, it can then... well, there's a check. I need to check if data is available before I can fill... Oh, if I want to make it non-blocking, I can put the receive call... Oh dear, make it non-blocking. Ow! I have my keyboard on a stand here, but the wheels of my chair, they... You know, I'm going to change chair. I'll switch to my kneeling chair. Right. How's that? Yeah. So the receive buffer. Yeah, we'll need to get ring. I want to make this non-blocking. Easiest way to make it non-blocking is I need to know if. Well.
Hello, Dino.
Shush. I think I could make it return a null. Pretty sure I can return an F string, return a null. We'll find out. I'm going to assume so. So then in that case, the first thing that actually I need to do some other stuff to make it non-blocking. One is I need to see if it has pending data. That's this code, but I'm just going to redo it. So first question is, does it have pending data? Oh, is that the first question? Could I be in a situation where I could ask for a string and it think there's no pending data, it doesn't return anything? This gets the string immediately, so the string can only be got once, so I think I'm okay. Let's try it. So then I check pending data, and that returns how many bytes of data I've got. Is that really the first question? Yes, if you number from 0. Think about it. Yeah. So, yeah, I'm not so sure about that actually, now I think about it. But anyway, there seems to be a bug in that. The philosophy, the words. I will get the number of bytes that are available. Is actually, I can tell that before I receive. So that's kind of interesting. And then I'll go if v is greater than 0. So if I have some pending data, I will get that pending data. I will add it to the buffer up to the limit of the buffer size. I will now need to search the string for the character 10. So I think I can do that with structure, very old school, on the, I can't remember the structure. Well, actually, maybe IntelliSense will tell me. Probably not. I'm so tired of trying to get IntelliSense to ever... Oh, hang on, it did it. Oh, there it is. Okay, it's got it. I've lost so much faith in IntelliSense, to be honest. So that take the string and it will give you a pointer to the string. And what happens if you can't find the string? I need to look up the documentation anyway. I mean, I could look for it manually. Structure. The character is not, it returns the null pointer if it's not found. So fair enough. Got the null pointer of uint8 star pointer equal structure buffer structure buffer and the character I'm looking for, which is going to be \n, like so. That'll give me a pointer to the character. If the pointer is not null, sorry, I enjoy not having to say if pointer not equal null in C++. It's a debatable issue whether you should say pointer equal. I've gone back to the old C style way because I find it easier to read. There's less noise. So if the pointer is not null, it means it found it, and so that means it's able to return a string. But I then need to remove it from. Okay, but okay, what I can do is star pointer equal null, string null. So that means that my 10 character has got replaced with a 0, and this is now a valid C string. So then I can do f string equal. Okay, I'm returning the string by value anyway. Return the string by value. To construct the string and return it. I'll put it into a temporary variable. I need to modify. Yeah, that's fine. I was just worrying about thinking about optimizations, but really probably don't matter at this point. So what I'm going to do is set this up to because I can yes. Okay, buffer. Yeah, I know. I should start my and carry on with my podcast of the moths of programming. I did one on comments. Always comment your code. It's like, no. Try not to comment your code. Try to make your code that doesn't need a comment. If you can make code that you don't need to comment, that's really good code. Notice I put a comment here. I don't use comments very often, as you can see, but here's a comment. Get string up to a new line. That's because I wanted to actually specify what this does, because it's not entirely clear from the name of the function. If I called it socket get string up to first new line, then I wouldn't need to put that there. But I can't remember which was the last one I did. Oh, thanks. I can't remember the last one I did, but there's a ton of them. It's like the compiler will optimize it for you. That would be a fun one. Wait, what topic would you like? If someone would like, tell me what kind of. So this, what for the moths of programming, it needs to be something that you hear said over and over and over again that's basically wrong, or if not wrong, is disproportionately stressed, and that can be it. So I did reinventing the wheel, just use boost. Oh dear. Did you hear that, Hal? Did you hear that? Just use boost.
Boost, boost, boost.
Yes. Just use unfortunately the podcast episode just used boost. The problem
Boost,
with
boost, boost.
oh, shut up. The problem the state management. That's interesting. I don't know what the opinions about state management are these days, so I need to know for it to be a moth, it needs to be something that's held as true but really shouldn't be. It's kind of flutters around in our brains and makes us bad programmers, and we often don't even realize it. So what's the angle with state management? But yeah, if I did an episode of just use boost, right? The problem with it is it would be about 30 hours long. It would have to be 30 hours long to do boost justice, really, wouldn't it? Does the B of boost stand for bloated? Oh no! Oh gosh, I never saw that before. Oh right, hang on. Got it. Boost stands for, right, bloated, object-orientated, superfluous technology. That's what boost stands for, and I'm so glad to have understood that now. Oh, all right. Well, this one is connected, right? So, Mark, what that's connected with is object-oriented programming. So, I believe people call it procedural programming. So, that grates like anything, because for me, procedural programming is more like programming with procedures. That's what that kind of means to me. I mean, a procedure is a function. I suppose it's done to avoid us going further and saying, well, if you're using functions, then it's functional programming. And no, functional programming is something completely different. But anyway, look, non-object orientated programming, or before object orientated programming existed in the C domain, it existed as something completely different that was envisaged by Alan Kay, which the most important attribute of which was extreme late binding of all things. Above all, that's what object orientated programming was about, supposed to be about. But when the concept got a sort of exactly the same concept, where only the name object was retained, eventually found its way into C. And at that point, it wasn't enough that we had functions and we had, you got me going, functions and we had structures. So in classical C programming, you have functions and you have structures, and this was not enough. There was a desire to sort of do an encapsulation of data with functions. That's how the class was born. There was also a desire to remove or make less needed certain features of the C language which were considered irritating, probably to academics. To touch on what I said earlier, it's actually connected to this topic, I believe. This is totally, purely opinion. I'm quite happy to be wrong. It's just the way it looks to me, is that basically the whole thing about engineers and academics meant that, you know, it feels this way. C++ was really an academic exercise. And one of the things that the academia wanted to do was try to hide certain features which maybe were a bit ugly when looked at through the idea or the view of creating some form that was almost mathematical in its nature, right? So one of the things you'd want to get rid of there would be, well, I mean, come on, it's really difficult. It's all to do with go-tos. Go-tos got a bad rap because of clickbait, except it wasn't clickbait, but it was the title. You know, the topic is very complicated. You know, Dijkstra actually wrote an article that it was he's credited with having said that go-tos are evil, and it isn't even true. He just wrote a very reasoned debating article on it, and to make it sort of more attractive, a clickbaity like title was substituted for it, which was go-tos considered not evil. It was, what was it? Go-tos considered, you know, bad in some way. I can't remember the word. It's just not coming to me. You know, and somehow this thing. But the thing you have to realise is that the academics, other than Dijkstra, who was also an academic, Dijkstra for me was you know, he's the old guard, if you will, and I think he had respect for the hardware, and the realities of you know, the underlying implementations, right? And I might be talking complete rubbish here, I don't know. But the thing is, that there is it's almost like ever since that became a thing, there's been this relentless attack upon go-tos in all forms, including execution addresses. It wasn't enough to try and hide the go-to. You also wanted to try and hide the idea of a pointer. Oh, hang on. What's going on? What the? Oh, emergency. Something just went really, because I'm talking about things, you see, that I'm not supposed to talk about probably. But everything has just gone screwy on my screen. I don't know if you can still see me. But now I have an issue that the... Just bear with me a minute while I try to restore normality. Oh my gosh! Right, let's get rid of that. Okay, I will. I think you can still see me, even though things are a bit weird, weird at the moment on my screen. So I'll finish off what I was trying to say. So basically, not only was the go-to considered bad, but also the idea of the program counter was considered bad. In fact, the program counter, which is something I've tried to get rid of in Phi, or I have got rid of in Phi within context of Phi. And it might be because it was felt that it caused problems. I don't know. But it's like I'm connecting various ideas together. Hang on, give me a minute. It'll come together. Fortran had a computed go-to. It had go-tos, but it had a computed go-to. So this was a go-to that you could actually take the address of where you wanted to go to and stick it in a variable. And in C, you could do a kind of almost similar thing. You could have a function pointer, but I think that function pointers were considered like really gnarly and nasty. So there was a kind of desire to hide the function pointer, and so from there you got the virtual table and polymorphism in the C++ form, and the polymorphism was implemented on top of inheritance, which seemed like a good idea, and admittedly it did seem like a good idea at the time, but there's been since proved to be actually a really bad idea. But don't you see, it's like try and hide certain things, and one of the things that seems to be like hidden over and over again is the address you jump to in one shape or form. So the V table is hiding function pointers, and when you go into C#, you can't even get the function. There's no such thing as an address. And so instead of function pointers, because that would suggest that it's pointing to some, it doesn't work that way in C#. It's not pointing to some memory that you execute in C#. It's a virtual machine. So that's why they're called delegates. And it's like there's this obfuscation that is all to do with trying to hide certain things that are considered perhaps not so clean from the perspective of from an academic perspective. You see this over and over again. Java doesn't have a go-to statement. Well, it has, the word is reserved, but you can't use it. Or Java doesn't have a preprocessor. So good luck to you if you need to do multi-platform development in Java. You can say, well, Java is supposed to be you write once and it run everywhere. Well, let's see how far we get with that in video game development on multiple platforms that have to use different, APIs and so on. Oh, well, you can just use, interfaces for that. But it's not very practical to not have the preprocessor in at all. C# realised this, and so you have at least got the if statements, which is the most important part. But you see, again, it's like there's been an attempt to clean up stuff. So how does this connect with what you were asking? Because yeah, I mean, the question was, let's see this here, because that was going all kind of bad. The reasoning. So the static methods really alludes to procedural programming, where what you do is the focus is no longer classes, right? And therefore objects. I mean, in C++, a class is an object. So they're called classes. They aren't called objects. It's kind of weird. But the focus in C++ is actually the classes themselves, and then you're supposed to make the classes which are invariably called nouns. They're nouns, and the verbs are supposed to be the things that you do inside them, and it's orientated around the object. But it turns out that this is actually really bad, because what it's much better to do is to orientate your code around things you do. So this would be verb orientated, and this is probably the biggest the biggest contrast between the two. Certainly in the way that that programmers, when they are programming, the way that they think is affected by this. So in a way, the issue, or the reason why I argue that it's better to avoid using classes or to stick with more C style than C++ style has actually got to do with the way it makes you think. When you program in C++, it's almost C++ in an object-orientated way, in the way that you're supposed to program in C++. What tends to happen is you tend to think in terms of objects instead of thinking in terms of verbs. And you end up with a very lopsided situation where things that should be verb-like are given noun names. So if you end up thinking all in nouns. So that sometimes the only verb that you'll get is do or execute. Does that make sense? It's like you create an instance of the factory and give it a blueprint. You give the factory a blueprint and requirements, and you set that all up, and then you say to the factory, do it. Which is, there's one verb in that whole thing, it's the word do. And you get back a thing. So it's like you end up thinking all in nouns. And this is terrible because it interferes with our normal reasoning. We don't go around thinking in nouns all the time. We think in nouns and verbs. We think about the things that we do. And as somebody who originally programmed in, before C++, I programmed in C, and it was very simple. You would create your data, and you would have your functions that operate on the data. And the two were kind of separate conceptually in the mind. There were two kinds of architecture going on. You would start off with your architecting your data, and then you would architect your functions that operate on the data. Both needed to be considered, but it was always the data that was the most important thing to think about first. And so your data is like your nouns, and then your functions are all operations that operate upon those. Those are all the verbs. And you spend most of your time constructing the verbs, because the verbs or working with the verbs, because the verbs are transforming data, and that is what you are doing. The machine is transforming data, and you state what you want in terms of verbs that describe the transformations that you want of data from one form to another. And that's very straightforward. But what I found, and I found this for myself as well, when I tried to embrace object-oriented programming, things became complicated. But I stuck with it because I thought, hey, you know what? It's my fault. It's something wrong with the way that I program. I started to doubt myself a little bit at one point. And going, so, what's going on here? Something was not working. What was not working was that suddenly I wasn't thinking in verbs anymore. I was having to think in nouns. So you have, the classic thing of there's the manager class. Sometimes you hear people who say, yeah, you really shouldn't have a manager class. Yeah, okay. But what are you going to call it then? So then it will be, well, but there is a reason. It's a feeling that says, what's wrong with the manager class? It's a pointless. It's a noun that serves no purpose. You want to know what things do, not what they are. You want to have, I don't know, a score manager. What does that tell you? It doesn't tell you anything. It manages score. Okay. How does it manage the score? You know, and this is a valid point, but it's a difficult topic because how can you resolve thinking more in verbs? I read that as being a case of we need to think more in verbs. But how can you do that if your whole foundation of your architecture is built on nouns? So there are other reasons why, but that's the one that came to me now. You know, objects are just too attractive, aren't they? They're too solid. They're too concrete. Verbs are not concrete. They're not as concrete as nouns. People are attracted to things which are concrete because they think that they are more reliable in some way. They think that there's less uncertainty around, this is a theory, there's less uncertainty around nouns. So when the idea came, let's make everything a noun, it took off like wildfire because it felt more secure. And I remember that's how I got hooked into it. And it took a long time to get away from that. I mean, it's only recently that I really completely said, you know what, forget all this. Just do what's right at the time. Don't be tied down to all this stuff. You know, it's like there's nothing wrong with using C-style code when it's appropriate. You know, there's nothing wrong with making every class a static class by default. That's what I do with my own code now. I make every class I treat as a static class. If it needs to be a class at all, it's static class. C# as well. Everything's static. Unless there's a damn good reason for it not to be. Now you apply that rule and suddenly everything becomes simpler. I can access things without worrying about where I put them. You know, the code becomes so much easier to work with. And it took a long time. I'm one of those people who believes that object-orientated programming was probably the biggest disaster. Let me correct that. Object-orientated programming, as it turned out and was applied to certain languages, as opposed to actually what it really was, is one of the worst things that happened to the industry. And it's all because of a word, object. If Alan Kay had chosen some other thing that was less concrete than the word object, this could have been avoided, perhaps. I don't know. Do you agree with me? Doesn't really matter, does it? So that probably more than you wanted to know on that topic. Yeah, Mike. That's right. Heretical view regarding global variables. Well, there you are. It's like, I do have one on that. Global variables are bad. No, they really aren't. We went too far in our attempts to banish them forever, and a lot of people who try to banish them don't understand why they were bad originally. And it just means that the good reasons for using global variables aren't considered. You know, they're very heretical, but you always forget to instantiate your car every morning. Exactly right. That's it. But instantiate's a verb. Instantiate's a verb, right? Because in the end, you can't get rid of the verbs completely. So what we end up with is an instantiate as being a verb, and there's an execute or equivalent being a verb, and destroy being a verb. So that's instantiate, execute, destroy. We're allowed those verbs, but everything else has to be made in nouns. Or as Yoda would say, instance of objector I am. Particularly bad joke of mine. Remember to destroy your car after you've done with it. Yeah, absolutely. So, okay, anyway, look, I'm spending no time coding and all my time ranting. Is that okay? I don't even know. I'm not sure what happened. My screen went blank. It was like Unreal did a weird thing. And then I've got a problem with, oh yeah, this, with OBS. Because I can't actually move the window anymore. Because the bar at the top, title bar, is off the screen, as you might be able to see. And so I can't actually it's crazy. So Windows doesn't really provide a reliable way of solving this problem when it happens. Oh, hang on. I managed to do something with the arrow keys. Oh, no, that was no good. Okay, I was able to maximize it. So now, you know, how do I unmaximize it and still be able to... Jeez, this is so annoying. It's like, it's so sad, isn't it? It's like there used to be keys for moving the windows around. You could do that by the keyboard. They got rid of that because, of course, they would, because they always get rid of, you know, that kind of thing, don't they? Things that we shouldn't need. That is so bugging me. I can have it full screen. Anybody know of a shortcut that will... I mean, you push left and right, it's supposed to make it jump between screens. Oh, okay. So, you know, we're back to auto it. There is a way around this. Because I'm just so persistent in my aim at defeating the demons of the computer that flipping heck. Auto it 3 script. Foo. That's the great thing though about doing your own code. When you do your own code, you can make your own rules, and it doesn't really matter if nobody agrees with you. It's your own code. The demons of computers. So, what am I doing now? My computer freaked out a moment ago for some reason and caused a problem with the layouts of the windows. And as a result, my OBS is now running with the title bar hidden off the top of the screen so that I can't move it. So this auto it to the rescue. Win move. And I hope someone from Microsoft is watching, because and feels embarrassed that I have to do this. I'm just saying, you know, because I can, and I'm a bit of a stinker. So I need to know what the name of that is, though. So that's the only... Oh, I know how I can find out a little bit here. I can maximize the window because I'm able to do that. Oh, it starts off with OBS. Okay. So we just win move OBS. Sorry, what was the command again? Win move, please. And then there's an X and Y. So I need to pass, and it's a bit weird, the text. Yeah. X and Y, 0, 0. Fine. All right, let's just do that. Now I can just run this script, hit F5, and there we go. And I have not been, I am victorious again. I beat the technology again. Ta-da! Auto it. Best thing ever. So let's just go back. Thank you so much. What is that? It looks like a crazy burrito. Oh, it's a party popper thing. Okay. So I looked at it. It looked like it looks a vaguely Mexican burrito thing, or whatever. Very colourful. All right. So I'm back to business. Socket get string, and I'm doing this old style stuff here. So F string buffer. And now what I want to do is copy the string down. I could use a str copy, but that's a little bit dangerous because there's overlapping memory. So we don't really want to do that. Unless I store it in another place. I think really just for now, for my sanity, I'm just going to do it like this. I equal, now it's buffer point. Again, this is not very efficient because I've got an actual, well, compiler will optimize it. Oh, yeah, okay. I buffer point, and then how much data is in the buffer at this point? Oh no, I added one to buffer point. To pointer. Do the recount. Oh no, this is nonsense. I just realised what I did there was utter nonsense. I was talking too much. I can't just do that. It'll put a back. It's looking for, no, hang on. No, it isn't nonsense. It's looking for, it scans through looking for the new line. It replaces the new line with the 0. It captures the string. What I'm missing is how big the buffer is. That's at buffer point was moved on. So yeah, pointer. Actually, why don't I do this? uint8 star p equal pointer. So +1. So I'm looking at the first character beyond. First character beyond the terminating 0 of the string, and then I want to make sure that it's a little ugly, but if we can do p minus buffer must be less than max receive length, so to the end of the buffer. No, actually buffer point. So buffer point being the end of the buffer filled. It's the point to which the buffer has been filled so far. So I'm going to scan up to the point, but not including that, because it's actually one past the current valid data. So we take P is equal the pointer plus 1, and then we make sure that P minus buffer, which is now the number of bytes in the string, are less than buffer point, and then we do P++. So this will move that pointer through the string, remaining string, and we do and I think I could try and be clever and avoid a variable, but it's not worth it at the moment. I equals 0. Right, yes, actually I can put that in here, so we can say int I equals 0, uint 8 star p equal pointer, p plus plus I plus plus. I could actually do it a different way, which may be even better. Uint. I will come back to this code because I really don't like it. Let's make a pointer called q, and that's going to be set to buffer. So q is set to buffer, p is set to the pointer. We're going to continue iterating through these with q++ until we reach the end of the current valid buffer, and we do star q equal star p, and so that's just going to do a copy down, and after having copied it down we can then move the buffer point down by the same amount. Interesting. So if I want to move the buffer point down, I need to know how much to move these down by. Yeah, all right. Well, let's just get that shift amount down here. It's, yeah, not entirely happy with this, but should hopefully do the trick. We're going to do the buffer point is wherever the amount that gets shifted down is actually determined by pointer plus 1, which is this one. So it's pointer plus 1 minus buffer, which is the start of the buffer. I mean, the issue is that the structure doesn't give me the index, it gives me the pointer, so I've kind of gone with that, but it's like I've got two different, am I using the pointers or am I using the offsets? But this is pointer plus 1 is the first character beyond the terminating character that was found. If I subtract buffer, then that gives me the number of bytes that I'm going to shift this down by, which I do the shift down, and I don't want to modify buffer yet because that will actually be change this check. So once the copy is finished, then I can do buffer minus, it's not my favorite type of coding, this, buffer shift. And in theory, this will have copied the string down. There may be a version of struct copy or mem copy that is safe if the regions overlap. I would Can't be bothered to look for that right now. But if you normally, when you do that, that's the reason why I'm explicitly doing it, because these are overlapping memory regions. I think. Are they overlapping memory regions? Oh, technically they're not, actually, come to think of it. Oh well, maybe I can replace that later. I've got this far now. And then having shifted out of the buffer, and then I've actually captured the string in S, I can return S. Psychedelic burrito. Yeah, that is what it looks like. So, who knows if this will work or not. But that should, in theory, return the string if it can, and then retains the next string if it, and then anybody asking for a string, it can check to see if there is a string. If there is a string, it will return it. The only thing I need to figure out then is what to do if it didn't have pending data. It will escape, and also if it couldn't find a new line, it will escape. This overwrite doesn't matter because that's going to be overwritten by the string as it's moved down. Buffer is wrong. I just moved the buffer, you see. That might have actually generated an error in the compiler, come to think of it, but it's buffer point that needs to be shifted. Okay. And if this doesn't work, there isn't anything, return null, null pointer. I wonder if that'll compile. Probably. Be surprised if there are. I'll be surprised if there are no errors. Okay, what's the problem? Oh! It's because I need to modify the header to include. Yeah, it's not liking this because it's not a member of the class. But I can just sort of cheat just to make sure this compiles. Right, okay, so this is structure. None of the two overloaded operators. All right, so what was the type? Cannot convert. What structure? Okay, let's see what it. Structure is a char, and I'm making it uint8. So, all right, let's make it a char star, and we'll see what the complaint will be now. No, it doesn't. Cannot convert all of the argument types. What? Oh, it's an int. For some reason, it takes an int, not a char. Weird. No, it still doesn't like it. Okay, so what are you complaining about now, structure? You take a string, a char pointer as the first, and an int as the second. And buffer is... Oh. Okay, let's try again. Cannot convert argument 1 from char star to uint8. Oh, these are always fun. Can't convert from char star to uint8. Lovely. So what we do is buffer is a pointer to a char star. if I add buffer point, I still get a pointer to a child star. What I need to do is recast this to a uint8 star. This is just bureaucracy. It shouldn't actually change anything. Cannot convert from char 256 to uint8. That's because buffer is okay. Buffer is an array. But also this is uint8. It should be able to do this conversion. We'll see. Next. Missing what? Comma before star. On which missing comma before star. This is, yes, probably this initializer. Oh. I think that actually, well, it's like multiple initializers. Cannot convert from char star to char. It's weird though, initializers in a for. You can't. I could get away with it because they're both chars. That's really annoying. Null pointer to, you can't convert null pointer to f string. I was afraid of that. So then we'll need to make this function return a bool. And why don't I pass in the string that I want to? I don't know if I can do that with an f string. I'll find out. F string and string, or let's say out put. Come on. Oh man, output put. Try not to look at the keyboard, but then so we can do that. Output get string. So what should happen here is then this will return false because it didn't manage to do it, and then this one here. Can I don't know if I can do that. Probably can't. Probably doesn't make sense. It depends how f string behaves. So output output can flipping heck. Autocomplete's not working. I don't know. Let me check because it must be will be the correct protocol for Unreal f string set reference. thing on here. Look at the F string. Look at F string documentation because autocomplete's not working as usual. I don't want the constructor because the constructor's already append, 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 begin, begin. Oh, okay. Convert contains. Bytes ends with find. I've not really looked through this before. Yeah, lots of stuff. All useful. Replace. Is there a set? RS. Sanitize. Serialize. No, there's no set. Is there an assign? From blob, from int, insert at, inserting, join by, left chop, blah blah blah. Remove end, replace. Replace with escape, replace, reserve, reset. Reverse, right. Right line, right pad, shrink, split, starts with to blob, to hex blob, to lower, up, to left, to right, to lower upper, to operator, get a pointer to the string, that's if it's a star, concatenate this path, / equals, return specific const, plus equal append, copy assignment. Oh, let's see. This would make sense. We'll try it. It's just that except that will probably throw an error. Types. What have we got? Doesn't like the fact that there is a F string. What? Bool F string. Yes, that's okay. Left a type in there. S undeclared identifier. Yeah, it didn't complain. Return true instead of that. Okay, next. Full Fazzle. Fazzle is not a valid thing. Right. False. And what have we got now? There is. All right. Success. That doesn't mean anything though. Is it probably not going to work? There's sufficient crap in here that this is probably going to crash. I can put some asserts in though, I suppose. Should I? Yes. Let's put some asserts. Let's put some asserts in. So the first one is that first assert is buffer point buffer point has got to be greater or equal to 0 and less than max receive length. It may be, except I'm putting, because I really don't want to crash Unreal. I don't want to crash Real if I can help Unreal if I can help it. So first of all I'm shoring it up. if we really want to get fancy, we can also check the connection socket is not null. Oh, come on, keyboard, please. Connection socket, assert that the connection socket is not equal, well, is. So connection socket. Right. The next thing is that before, because yeah, that's fine. Nothing will go wrong or crash if buffer point is within that range. We should be good. Yes, okay. So then buffer point plus read count. We're going to do the structure, the search on the buffer. That should be... Oh.
Hello, Dino.
Shh. Problem with that is that that's bad. Doing code review now. That's bad because the this searches for the string up until terminating 0. There may not be a terminating 0. Tut, tut, tut. I have to do a structure instead. Structure, which of course is not there. There might be. This is right. Okay. This is a Bill Gates moment. Oh no, maybe not. It's called memture. I apologize, it's not a Bill Gates moment. Memture. Come on. There we go. Memture is a buffer and the value it's looking for and the max count. So, as I thought, so this needs to search throughout buffer up to maximum value of this. I need to check the documentation though on memture. What's the return value? Oh, you're annoying. Memture. The return value, a pointer to the first occurrence. If the value is not found, it returns a null pointer. So I think that fixes that problem. So, okay, but looking at it, well, buffer is fixed. That's nothing to look for, to worry about. This should not be able to crash. So we should be good. We check to make sure that the pointer is not null, so we should be fine. If the pointer is not null, and given what we've seen there, we should be fine to set that value. We set, having done that, it should be fine to set the output string to that. Then we do initiate the shift, and then we move the buffer point, and return true. Right, so in this copy here, we can be really pedantic about this, and I'm going to be, because I really want to try and avoid a crash just out of principle. And what we can do is check to make sure that Q is greater than or equal to buffer, and Q is less than or equal to buffer plus max receive length, and P is greater than or equal to buffer, and P is less than or equal to buffer plus max receive length. So basically I'm making sure on every copy that it's inside the buffer. If at any point either of those pointers are outside the buffer range, mistake, like you're less than, not less than or equal to. It's the problem with asserts, is that your asserts could have bugs in them. Right, so I think that's good. And now what we'll do is switch it back to this guy. Oh yeah, actually, funnily enough, I'd have been better off to leave it, to copy it first before I did that. But anyway, and then we'll do V here. Let's copy this and paste here and remove that. And I've lost the F. And make it a static. And anything else? All right, let's see if this compiles. Taking extra long because it's having to recompile all of the reflection, or redo all of the reflection by analyzing the header files. Taking a long time. This is why I avoid modifying header files as much as possible. And errors. Okay. Syntax error. Yep. Yeah, you are right. You know, I normally don't bother doing more than one, fixing more than one error before trying to do a recompile, because usually the second error is often meaningless. I cannot convert from void star to char star. From void star to char star. I see. Star, please. Oh no! Why don't I just go char star? And the next error, output unidentified oh, look, yes, because I copied and pasted the other thing, and so that was caused by copy paste. Okay. Oh, and another one. As I'm looking at this, this needs to be returning a bool, which also this one needs to be. And this isn't the right thing either. Now, no wonder errors. F string and string. And I modified the header file again. And it failed again. Not all control paths return a value. And that be very true. I went to that being in the wrong place, because I need to make sure there's a return if it asserts. So anywhere in here that it asserts, it'll jump out of this block and then return false. Okay, try again. It succeeded. Eventually you will succeed. I'm going to stop playing. It's done the hot reload, and then always a good idea just to run the thing before you try and use. I just like, you know, run what I had before. and make sure that's still working. There's absolutely no reason why it shouldn't, but it doesn't really hurt to make sure, because if this does fail, then it means we're in one of those, you know, strange situations. Yeah, that's all working the same as before. And now, in theory, if everything works, I should be able to wait for a string. I mean, all of that was try and do that. So to test this out, what I'm going to do is wait for the connection, and then I'm waiting for pending data. So that's all of this block, including that, all of this. Stop playing so I can move. All of this, I'm going to move over here, because this is my test rig of pulling single characters out. And then I'm going to take this here and do socket, and I should see them all here. The one I want is socket get string. Oh, so I've got socket get string. Should, why is this here? Oh, it's the string I want to fill. Yeah, I forgot them because I'm doing this. That's really awkward. I don't want that. Okay, I don't want to do it like that. Okay, so what we'll do is I'm going to change my mind here. So right, oh, come on, copy, paste, paste the F string. I still want to know if it's valid or not. I'm not allowed to return. I wouldn't normally do it this way, but this is for blueprints. So we need to know if it's valid or not. To know if it's valid or not, I need to return a Boolean reference. This feels like sledgehammer to crack a nut when you do this. So it's like so. So in this way, oh God, I can just create the output like this. Will work. Oh come on, F string output. I'm just going to return the output. If there's any failure, it returns a null string. If it returns an actual string, received equals true. If it gets to here, received equal false. Maybe even better is just to do this. Received equals false. Good night, Tropical. Take care. Thanks for tuning in. Received is set to false, and the only place it's set to true is when there's a valid output. And all right, we'll try this. And it's another error, and that's because I need to, change this in the header. It's returning an F string. Boolean ampersand received. And it's an error. Dennis, that's funny. There was the weird Sixth Sense thing. Because I looked at the chat and then it popped up. I'm fine, Dennis. How are you? So, output undeclared identifier. Really? Oh, that's why. And that's done. So, I'm going to have to get rid of that. Socket get string. I can get the return value, which I can then print. We'll do ourselves a print. We print string. Oh, I've been up to lots different things. I can print the string. It'll print a blank string if there wasn't data to receive. Ah, right. But yeah, so what I need to do, in fact, is to go from here to I print if there is a string. That works. I need to branch. So we're going to do a branch depending on the condition. So if it's true, that we received it, we print it. And then I need to go to a delay node. With a 0 time, which is a delay of 1 frame. And goes like this. So if it's true, we print it. If it's false, we just go into the delay. Like so. And then at the end of the delay, we go back to here. So it basically is a loop. It's going to loop. It tries to get the string. If there isn't a string, it just goes back to the delay. No real nice way of making that, is there? If it can print the string, it will. If it won't, if it can't, it just goes to the delay directly, and that's the way it goes. And so we'll see if this works. Let me save it. It'd be nice if this worked. Who knows? Who knows if it'll work? I'd find out. That'll be probably the end of the stream at that point. It'd be a good place to leave it. So what I'm hoping to see, really hoping to see, is that when type in here, it appears in the chat, in the log. Probably going to crash, despite all my efforts. I can't believe it. Worked first time. Hello. But this, I suppose, is when you are really careful. This is... I did not expect it to work first time. And not a single assert fired. Hello, this is great. So now I am able to receive strings. So that's great, because from there, it's only a short hop to being able to create objects. I'll need to parse the strings. I'll do something like, you know, sort of create cube. I'm probably going to do something like create cube foo. Oh, guess what? It was all going so well. Maybe I did deletes. Oh, no, it's fine. Those are deletes. You hit back and control characters from the terminal. That's believe me, honestly. So it will do something like create cube foo, and then we could say move foo 10, 20, 30. So that would create a cube and move it to 10, 20, 30. If I use names for things, then I don't need to have bidirectional communication. I don't need to sort of like say on this, I don't want to sort of like create cube and then I get back an ID. That's pointless. Might as well do create cube and I'm calling it foo. Thank you very much. And then afterwards say move foo. I like that particular kind of API. It makes a lot more sense. And so then I can also I'll be able to add rotations and whatever else. And so it's actually getting really close to me being able to create this terminal, especially because as I say, I don't need bidirectional communication at this stage. This will pretty much do the trick. And this is done with blueprints. What I think I'd like to do is to put this node here into a C function of its own, and then I'll have a node that just waits for a string to come in. Really, and when that comes in, I can call whatever other blueprints I want to call. This is really quite sweet. I think from the command point of view, things like create or move, I will make a map in C++ to connect these to different different blueprint functions. I need to think about how I do that. Maybe I could make these create events. That's probably better. Create events and the events trigger commands, but I will figure that out next time. Okay, well, yeah, more ranting than coding, but still got somewhere. So until next time, thanks for watching, and take care, everybody. Have a good night. See ya.